When a metal rod is deep in its salt solution, then potential produced is known as electrode potential. And when temperature is 25 degrees centigrade and concentration of salt solution is 1 molar, then electrode potential is known as standard electrode potential. Remember that whenever there is a formation of electrical double layer, a cell potential is developed. Now let us discuss about EMF. As you know, a potential difference produced due to flow of electron from electrode at higher potential to the electrode at lower potential is known as EMF. Remember my friends, EMF is nothing but a potential difference. So in this sense, potential is nothing but EMF of a cell. So cell potential is nothing but EMF. Now let us discuss oxidation potential and reduction potential for a half cell. As you know, whenever a metal rod is deep in its salt solution, then it is known as half cell. For example, if zinc rod is deep in ZnSO4 solution, then it is known as half cell. About half cell we already discussed in part 1 of electrochemistry. Now this is a half cell in which a zinc rod is deep in ZnSO4 solution. So cell reaction occur here as Zn, it gives Zn2 positive plus 2 electron. As you know, this is loss of electron, that is nothing but a oxidation reaction. Now due to this oxidation reaction, what happen? That 2 electron get climb on a rod, whereas Zn2 positive ions enter into the solution. So in solution, positive charge is present, whereas on rod, negative charge is present. So there is a formation of electrical double layer. Now since this double layer is formed due to oxidation reaction, that is Zn, it gives Zn2 positive plus 2 electron. So here potential produced is known as oxidation potential. Now in this case, if temperature is 25 degrees centigrade and concentration of salt solution, that is ZnSO4 solution, is 1 molar, then potential produced is known as standard oxidation potential. Now let us discuss reduction potential for a half cell. Now as you know, if copper rod is deep in CuSO4 solution, then here reduction reaction occur as Cu2 positive plus 2 electron, it gives Cu. Now since here electrons are present on left hand side, so this is gain of electron. And as you know, gain of electron is nothing but reduction reaction. Now here Cu2 positive ion get deposit on a rod, so on rod positive charge is present. Whereas as you know, CuSO4, it is dissociate as Cu2 positive plus SO4 2 negative ion. That means SO4 2 negative ions are present in the solution. So on rod there is a positive charge, whereas in solution there is negative charge, that means there is a formation of electrical double layer. So here this electrical double layer is formed due to deposition of Cu2 positive ion, that is nothing but due to reduction reaction. That's why potential produced is known as reduction potential. Now if temperature is 25 degrees centigrade and concentration of salt solution in this situation, that is CuSO4, is 1 molar, then potential produced is known as standard reduction potential. So this is all about oxidation and reduction potential for a half cell. Now let us discuss oxidation and reduction potential for complete cell. But before that, let us discuss what is solution pressure and osmotic pressure. So as you know, whenever zinc rod is deep in ZnSO4 solution, then oxidation reaction takes place, that is Zn, it gives Zn2 positive plus 2 electron. This tendency of rod to lose its ion and send it into solution is known as solution pressure. Whereas if copper rod is deep in CuSO4 solution, then what happens? That Cu2 positive ion get deposit on a copper rod. This tendency of electrode is known as osmotic pressure. Now let us discuss oxidation and reduction potential for complete cell. Now, as you know, oxidation and reduction potentials are equal but having opposite sign. That means for any cell, if oxidation potential is plus 4, then definitely its reduction potential is minus 4. Now let us take these three cases. First case, if solution pressure is greater than osmotic pressure. Now in this situation, oxidation potential is higher, whereas reduction potential is lower. That means if oxidation potential is 6, then reduction potential is minus 4. So 6 minus 4 is equal to 2. So balance is of oxidation potential. That's why here potential produced is known as oxidation potential. Whereas in situation 2, if Ps is less than Po, that is solution pressure is less and osmotic pressure is more. So in this situation, that potential produced is known as reduction potential. For example, if oxidation potential is 4 and reduction potential is minus 6, then 4 plus minus 6, that is equal to minus 2. So balance is of reduction potential. That's why potential produced is known as reduction potential. Now let us take case 3. Here solution pressure is equal to osmotic pressure. So if these two potentials are equal, that is oxidation potential is equal to reduction potential, then how much is the potential difference? So as the name itself indicates, it is a difference between potential. So if two potential are equal, then its difference is 0. So here no potential is produced. So at that time, this electrode is known as null electrode. Now let us discuss how to measure potential by using potentiometer. This potentiometer works on Poisson-Tropsch principle. This principle was given by Poisson-Tropsch in 1841. According to this principle, if an EMF is opposed by EMF of another cell, then no current flows through the circuit. As I told you, cell potential is nothing but EMF of a cell. Now suppose this is a standard battery. This is a battery whose EMF is known to us, and this is the battery of which we have to determine EMF. This is high resistance wire AB, and this is the key. Okay. This is galvanometer. As I told you, Poisson-Tropsch principle is that whenever an EMF is opposed by external EMF, then no current flows through the circuit. Now let us discuss working. First of all, bring battery ES into the connection by using this key. Now suppose that as per Poisson-Tropsch principle, no current flows at point X dash. Now bring this battery EX into the circuit and again move jockey. So what happens? EMF of this battery is opposed by this standard battery. That means no current flows through the circuit. So let's just suppose that this is the point X where no current flows through the circuit. Now length EX is directly proportional to EX, whereas length AX dash is directly proportional to ES. Now by taking ratio of these two, what do we get? That length AX upon length AX dash is equal to EX upon ES. That means Ex, that is EMF of unknown cell, is equal to length Ax upon length Ax dash into Es. So in this way, if we know length Ax, length Ax dash and EMF of standard cell, as you know, it is already known, so we can calculate EMF of a unknown cell. So thank you for watching this video. In next video, we will discuss Nernst equation.